Okay, so I've done some videos on equations. This one is going to be on some worked examples for equations. And the equation I'm going to pick is the one for moments. And the reason why I'm picking that one is because it's a year 8 one, which means that most people will have seen it. So let's just start off. And you may notice that this looks familiar to you because this is also the equation for work done. So force in newtons, distance in meters, moment in newton meters. Okay, and what this distance is, it just means distance from the pivot, okay, rather than distance travelled, which was the one for work done. So that's my equation. Here's the example. Okay, so it says, Figure 3 shows a toy suspended from a ceiling. The star on the toy has a weight of 0.04 newtons. So based on what I've said before, the first thing I'm going to do is I'm going to write down weight 0.04 newtons. I don't know if I'm going to need it yet, but let's assume I will. And if I don't, well, then there's no harm in writing that down. But that's how you get started. That's how you break these questions down. Okay, so the next thing is it says, and there's a distance 0.3 meters from point P. And it says, so I'll write that down. So let's go. Distance equals 0.3 meters. They've very kindly given it to us in the right unit, so we don't need to do anything with the units. It then says calculate the moment. Okay, so all we're now going to do is put it into the equation. You can check my workings if you want to see if I've got a power of 10 error there. Okay, and see how easy it is because I laid out this bit of the workings, so this bit then becomes easy. Another bit on my workings is, can you see that I've done m equals and then equals and then equals, and I've put all my equal signs down next to each other, underneath each other, and I haven't touched this side at all. Never just keep going equals, 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 equals. It's really bad maths layout, and it will just cause you to have lots of errors later. Okay, so let's see if it gets a bit trickier. It then says the star and the crescent moon balance each other because their moments about P are equal and opposite. Calculate the weight of the crescent moon. And it says the moon is 0.2 meters away. Okay, so we've got our star, we've got our pivot, and we've got our moon. And what we're saying is, we're saying that the star is 0.3 and we're saying the moon is 0.2. Okay, so that's sometimes a quick little diagram can help. And we know that the star had a weight of 0.04, and now we want to know what is the weight of the moon. Okay, so do the same thing as what we did last time and lay it out just the same. So we write down which equation we're going to use. We're going to use moment equals force times distance. We write down that we know that our distance is 0.2, so we go distance equals 0.2. We don't know what the weight is this time, so we're going to put weight equals question mark. But we do know what the moment is this time. And we know that the moment must be this one here. Now, let's say I didn't calculate that right because I didn't use my calculator. And I'm not very good at times and two decimals together. I sometimes make power 10 errors. I would only lose 1 mark for getting that wrong, and I wouldn't lose any marks on this part of the question because that would be error carried forward. So I'd be that, try not to do it, but it's not the end of the world. It's much better that you get onto the rest of the question than worry about the bit you didn't get right earlier. So we know that moment equals 0.012. So then I'm going to put it into the equation. So I'm going to go 0.12 equals the force, which we don't know, times by the distance, which is 0.2. I'm then going to put my tram lines either side. Now I want to know what F is. I don't want to know what 0.2 of F is, so I need to get rid of this 0.2. So in order to get rid of that 0.2, I just want to have F on its own, so I'm just going to divide by 0.2. And whatever I do to this side, I've got to do to this side. If I've got my maths right, dividing by 0.2 is the same as timesing by 5. So I'm going to go with, that's going to equal 0.6 newtons. So I'm going to say F equals 0.6 newtons. Okay, the next one on this page is a wheelbarrow one. I'll post another video in a second explaining how to do wheelbarrow one, but I think it might be worth you giving that a go on your own before I do that. So here is the wheelbarrow one. It says that it's 1.4 meters there to the handle, it's 0.45 meters to the wheelbarrow, and it says that a vertical force of 48 newtons would need to lift the wheelbarrow legs off the ground. And then it says what is the combined weight of the bag and the sand of the wheelbarrow. Okay, so force here is 48, distance here is 1.4, distance between these two is 0.45. What's the weight of the barrow and the sand? Okay, and I'll do that one again in a second, but I think it'd be good for you to do it first before I do it. This is in the so on Caboodle, this is on page 132 of the blue book. Okay, I will upload a picture of that anyway.